So we have y is equal to cos inverse of x. We need to figure out y2 in terms of y alone. So the double derivative of y with respect to x, it has to be, the final answer has to be in terms of y alone. It would be a smart thing to handle this cos inverse initially. What I mean is applying cos on both ends. So we end up with what? Cos y is equal to cos inverse of x. Actually, you can skip this step and you can directly write it as cos y is equal to x. This would be convenient. That's what I mean. Okay, let's differentiate with respect to x, and we have minus sine y prime is equal to 1, right? As per the chain rule. This is as per the chain rule. Okay, keep this in mind. Now we can rewrite this as y prime is equal to 1 by minus sine y, that is minus cosec y. Now again I can differentiate with respect to x, and I end up with double prime is equal to minus cosecant y into secant y, right? Sorry, cot y, my bad. Cot y into the y prime. Again, this is because of chain rule. But what is y prime? Y prime is minus cosecant y. And by the way, the derivative of this is going to be plus, minus of minus plus. And so this is plus. And when I substitute y prime from 1, so this I'm calling it as 1. So we have this to be equal to minus cosecant square y into cot y. So that's your answer. So one last time, I expressed the x in terms of y because it's way convenient to handle this scenario, which turns out to be this. It's very convenient than doing anything else, because our final answer has to be in terms of y. As you can see, it's only in terms of y, there is no x, and so this is the best way forward. If they're not given any such condition, then you could have normally done it, right? Next thing, I hope I didn't confuse it over here. I had a negative, and derivative of cosecant y itself is minus of cosecant y cot y. So minus of minus becomes plus over here, right? So nothing else. And yeah, again, when we substitute y prime, which has a negative, so positive of negative is negative. So this is your final answer.